Hey guys, welcome to the channel. I have another marine ECM test. This time working in Volvo Penta. This is from England. I'm going to just flip it over so we can see that we have no markings or anything in there. Even though some of the numbers are close, these 1981 is different than the other computer, which I'm still working on. The Wake Falls Marine. This is the Wake Falls Marine here. I will record a video. I just did some of the repairs and not good luck for this one. So I'm going to record one for the customer so they see what is going on. Um, this is, I see that I removed from there. I'm going to do some more testings and everything, but yeah, so this is a very intrusive repair and not good luck with that one. But yeah, coming back into this computer again, his name is Oliver Nutt. Make sure I don't have much of his information, but you can see in there that's his address in England. So Oliver, this is your computer now connected to the simulator. Fiable reference is good. I got all working normal. I have probably run the computer for no more than 10 minutes or so. I'm going to give you just walk through what I have connected. So in blue channel, this is the oscilloscope that we have connected, and this is my picoscope here. So we have the fuel pump activation measure. Even though I have the bulbs in here, I want to show also that that is indeed working. Um, and the reason it's light up is because the computer is pulling it down. When there is no ignition, my simulator is supplying 12 volts, kind of like through a relay, the same way it works on the boat. So that's blue channel. The green channel is connected to injector number one. The green channel is connected to to the EST signal. Your setup uses just one EST signal, so one signal for the coil and then distributor, right? And then the yellow channel is connected into the IAC activation, which again, I have a special tool. This is not just LEDs in there. This is a special tool that will change colors and it tells me if it's activation on the IX. It's specifically for IX. Everything is working. We have all the 8 injectors, 4.3 milliseconds, and that also depends on the values that I'm giving right now as far as map sensor, barometric pressure, throttle position, etc. Right? So, but it's running good. So we have this capture. I'm going to take a picture and attach it to your folder. All right, save the picture. I do have um, I do have a folder already created for Oliver, which the first thing that I do when I connect the computers is I save the first capture with not an engine running the first report, not the first capture. You can see I have here 0 speed, and then read the folder where on the boat or in the module, right? So we got TPS, voltage low, barometric pressure low. This actually is happening here because I don't have the barometric pressure sensor connected. Three sender, all that has 0 most likely are happening in here. I don't have the three sender connected, not his concern. Oil pressure sensor switch voltage high. This is um, one time. So all that has at one time was there. So again, we have CKP signal loss. Again, the IX we can disregard. Um, Ignition relay open one. Again, that's his. Um, that's uh, that's it. Year of these computers is 2009, so that is the information he sent me. It's a 2009 Monterey 214 FS, and this is a Volvo Penta 5.0 GXI. I have his serial number, which is 4012 25 23 61, and I always attach that to the, we have it here, but I always attach it to the tab to compare and make sure that what we have, this I input, this is in the computer. Sorry if I go a little too fast in here, but this is the information the module has inside. So we are know that, yeah, the serial number is perfect, correct. So this is the original ECM for the boat. Right, so what I'm going to do, oh, I forgot to check that history because I want to see how many hours were when I first got it. And we can see that in here. Let me just go back. So 45660, and right now we have, so 45660, 45675. So like around 15 minutes running. So what I'm going to do is I'm going to turn the computer off. We're going to lose communication. We're going to see that popping up in the screen, and you can see that is indeed happening. I'm going to turn the ignition on. We're going to see the main power coming on, and then the fuel pump relay. So it is all working good. They will probe out and then come out. And then we just start the engine, and we see immediately injection. That will start to get to normal values as soon as it goes into fuel in the crank and everything position. But everything is good. We have again all the injectors, all the 7 injectors. I got LEDs. The simulators tells me everything pretty much by light. The ignition is the only one, the ignition EST signal. That's how it's called on this boat. It's only one again, and I can see that it's blinking. But the best way to see that, and that's what I use, the oscilloscope. We know that we have a very nice and steady 5-hour signal. That's the way this signal for the EST should look. A good, very good oscillations on the injectors signal. The IAC will change, depends on the speed. If I change, because I got 20 milliseconds per division, if I change this to longer time base, so we got now 20, 200 milliseconds, then we can see more of the activation on the IAC as the boat is trying to change and keep the idle in control. Again, that's all working good, no problems at all. And we can see that the fuel pump relay is in zero, which is the way it should be. So I'm going to again turn the boat off. As soon as I turn this off, we can see that now that signal on the blue channel goes up to 12 volts again. Now it's off, but as soon as I'm going to just turn the everything on again. We'll see the change. I'm sorry, 1 second, guys. Yeah, you saw that in there. So I'm just switching ignition on and off. If I stop this, it's just an on and off relay uh, captures them. I don't have to really do that. But what I want to show to Oliver is that indeed we have immediately injectors. Again, this is going to take like 2-3 seconds, and then boom, it goes into the normal state. We got main power relay, fuel pump relay. The computer is working good. I'm going to, again, this is now a stop because I was trying to show something to you guys, but I don't think it's really necessary. Um, Everything is working good, Oliver, here. For my subscribers, let me turn this lamp off because it gets a little reflection on the screen. Um, I'm using the 6402D picoscope. It's a really, really capable oscilloscope. This is 1 gigasample oscilloscope. So this is a higher line, very good oscilloscope. Um, you will see and say, well, it's only a 4 channel. It's probably the same as the 4425 for the automotive. It's not. The buffer on this oscilloscope compared to the one in the automotive is huge. I mean, this is like, it's a big, big, big difference. And I can show that. I mean, for those that are familiar to see my videos on the automotive side. Probably Steve Kaminsky, if you're here, he's one of my coworkers on Bavaria Motor Repairs. I want to show here that with this oscilloscope, I can change the sample rate and go up to 50 or more uh, mega samples. I want you to see this in here. In picoscope, when you're trying to do sample rate, this will not go higher than 30 million samples per second. And this one, I can go, as you can see here, 1.25 gigasamples. So this is a huge buffer. It has so much capability to record signals, and that's why this is a bench test oscilloscope. Because when I'm checking the internals on the computers to go for communications in between, let's say, components, like the one on this other customer, Wake Falls Marine, uh, these I see right here. which controls the fuel pump relay and the main power relay, injectors, and some other internals on the computer. It controls them and it has diagnostics, but is controlled by the microprocessor. So this communication between this IC and the microprocessor is called SPI. And I can show you that actually because I have the data sheet. Let me just get it open up. I don't know if I close it. I think I might have. So give me just 1 second. I have all the information and I don't mind sharing it. Let me just make sure I get it. Let me see what it is. These are just the diagnostic manuals. Did I went too much? Data sheet for microcontroller. I just have it open. Oh, it's right here. Mm-hmm. All right, so as you can see, this is a smart octa-low driver. So I'm just going to scroll down a little bit, but yeah, this is the way this driver, again, the one right here, this is the one that controls, again, the fuel pump relay and all the stuff that I just tell you, not the injectors, some other things, but yeah. So we have the control, the communication in between these slave IC to the master, which is in this case the microprocessor, and it has also inputs. It has also direct inputs if you want to. I mean, it can be used as analog inputs or and then control the outputs that we have on the right side, right? So it has 8 outputs. It has 4 analog inputs that can be controlled by power. It's still a logic inside the IC that will take command because it will know if it's a serial interface command coming from here and then control the outputs, or if it's an analog deep signal that is controlling, and then again it will control the outputs. These are a heavy kind of like a H bridge controller or IC that you will see mostly on marine ECMs. But yeah, just to share a little bit of what is inside here. Again, Oliver, I have your computer running. I'm going to turn it back off again. And this is what I do always in this test for customers, especially, when it's a computer that is coming overseas. Thank you so much, Oliver, for trusting in us and sending this our way to test. And I know for sure sometimes it's very hard to have marine technicians they evolves and they have tools correctly to see all the signals and everything. And then that's why it needs to be sent to facilities like mine. But yeah, so again, ignition, we have seen main power relay, now fuel pump. This will prove out and then run 2-3 seconds. It will go from 1.5 milliseconds, and this is a normal start, and then completely now running engine. This is a strategy the manufacturer uses so you don't overfill the injectors at first cranking. That's just the way boats are because they use a lot of fuel. This is not on the automotive side. We will not see anything like this. But yeah, so everything is in control. If I change the map values, let me just change this. So if I change the map, look at the response immediately on the injector. So the computer is in complete command and complete control of the injector milliseconds. And so is in the EST signal. But yeah, so everything is cranking, everything is firing. I don't have any fault codes, not the ones you had before there. So again, Oliver, I will be testing more, probably around keeping the computer running for an hour and then send you the report. But so far, I don't see anything that is part of your concern. Thank you so much again, guys, for watching the videos. Hope you like the content. I am trying to show how I do the tests on the tests on my lab here and how I am actually hands-on work. There's a lot of facilities around there that they tell you they repair computers, and I mean they might repair coil or injector driver because I mean those are very easy to do, and but they don't have the knowledge. I have take hours and hours and hours of study. um, a lot of people ask me, where do you learn to repair computers? It's a lot of stuff has been self-taught. I went over to college and have an electrical engineer, but this is my love, let's say, electronics have always been in automotive my love, and that's what I wanted to do for my life. So this is what I also enjoy doing so much of this. And for the marine side, I just start looking for data sheets of the components and try to put, the puzzle together. I like the challenges like that, where is the signal going? Do my own schematics, because again, there is no schematics for this, but you can understand if you start, taking a board. Let me take you a little more. Give me 1 second, guys. Since I'm talking about this, I want to show you the face. So this is the same computer we had there and here. It's different ones. I have another one in here that you might externally think is the same, but this is not. This is a newer module. This is CAN communication, and let me just put them on top of that one, or actually, let me just. Um, I can probably put it there. Yes, perfect. So, and we will be able to see better with this one, even though I have, as you can see, removed the microprocessor from this one. If we see here, let me just go, where is the differences in here? Let me just see. Yeah, we have the same in here, the same in here. So actually, no, that one is the same. I thought it was, maybe I had it backwards and I thought it was a different computer, but no, it is the same. So yes, this is a lightning strike computer that com customer never requested back. This is one that I got the same thing. I took everything apart and away from for me to do tests, because as you can see, there's a lot of components that are under the connector. This is a 90 pin connector, the 90 solder, and as you can see, everything, the board is intact. But then I can follow all the traces back to the microprocessor, from here to the microprocessor communication, so I know exactly where everything is going. I did my own drawings, my own schematics, and yes, this, I probably put 116 hours on this computer. Yes, I know it sounds outrageous, but it is true. I mean, in order to find each component, because there is no data sheets, or all the mask, most of the components in here are numbers you wouldn't be able to find online. So you have to understand how it works to try to compare to a known, another one, and then use it. Some components, they do have the marks, especially injector drivers and little things like that, but not the rest. But yeah, this is, guy, what I do, and I take my time in order to make sure that when I give a recommendation to a customer, I just dropped that one, but yeah, that's not important. But yeah, like I said, I take my time to do my homework, and then with with possession, I can tell the customer, yes, it's not repairable. I cannot go any further. There is some things that we can and we cannot do. In this case, Volvo Penta, there is no calibrations. There is, you can transfer the microprocessor, but there is no tool that I at least know of that I can remove that information from a no mask microprocessor and then move it into the other ones. And again, there is no way to find that microprocessor. So the only one will be is to take a microprocessor and then move it into a new computer. But yeah. So again, guys, yeah, I don't want to take much more longer. This is already almost a 20-minute long, and this was for customer as well. But yeah, this, I think, is important to also show Oliver the time that I take to do all these tests, and that he can also trust in what we do here. All right, guys, thank you so much for visiting the channel. Again, Oliver, thank you so much. Don't forget to subscribe. See you next time. Bye bye.